Welcome to this series, competitive coding of 31 problems. So this is like picked some 31 problems from Leet code, and I will be trying to cover all the strategies that are required and to gain some confidence in competitive coding. And so today I'm going to start with this linked list. So just before jumping into the problem statement, I'll just explain in very short what linked list is. You can see in the diagram here 1 2 3 4 5 with the arrow. What does this arrow means? So if you remember array, it was like elements were stored continuously one after another in an it was also in the memory. It was also stored continuously in a continuous way. But in linked list, the only difference from the array is it is not stored in a continuous fashion. For example, 1 2 can be like this, 3 can be here, 4 can be, let's say, here, and 5 God knows, it can be like from it can be here. Okay, and this can be the storage way, how it is like stored in the memory. But in the representation, like if you have to reach to second element, you can reach from 1 because 1 has the address of 2, and if you want to reach to 3, you have to start again from 1, and then you have to go to 2, and then you can go to 3. You can't directly just jump to any element you want, like in array, because in array you can the length of the array, and you can just calculate index. If there are like 10 indexed array, you can go to second index, you can go to 5 index. But in linked list it's not possible, simply because elements are not stored in a continuous way. So you can't do maths, and you can't jump to any address possible. But every time you have to start from the head, and you can reach wherever you want, but you have to start from the head element. If you have whatever address you have, like if you have head, then you have to start from head, and if you have address of 3, then you can go to 4, like that. Yeah, so in this problem statement, we have to find the middle of the linked list. Had it been the array, it's very simple. You have to calculate the length. You can divide the length by 2, and then whatever index you can return it. In linked list, if you have to return the middle of the element, let's say in these two case, if it is odd, you have to return 3. If it is even, you have to return 1 plus 1. So basically you have to start from the beginning. Okay, but how do you know if we have come to the middle? Like, how do you know if I started from 1, and let's say if I have reached to 3, how do I know like 3 is the middle element and I can return it? So one pointer, you cannot know it unless you reach to the end, and you can assume, okay, I have reached till the end, so maybe somewhere some element will be some middle element. So one pointer you cannot judge it, so you have to have like 2 pointers here. Okay, 2 pointers. So one pointers can be moving 2 steps at a time, okay, in the loop, and second pointer can be moving like 1 step at a time. Let's say I have started a loop, okay, starting from the head and until I reached to the null. So after 5 there is null. Okay, let's say 1 2 3 4 5 and null. So if I have reached from head, if I reach to the null in the loop, then yeah, so one pointer I can move 2 steps and I can reach to the null. While I'm moving one pointer 2 steps, I can move the other pointer only 1 step. So let's say one pointer is moving like from 1 to 3, and the second pointer is moving to 1 to 2. So second pointer, while the first pointer will be at 3, second pointer will be at 2. Next time, while the first pointer will be at 5, second pointer will be at 3. Next time there is no other possibility to move, so we will return 3, the second pointer. Okay, so this is very simple. We have one pointer, we have to move 2 steps, and the other pointer we have to move 1 step, and at the end of the loop we have to return the pointer that we made it to move only 1 step. So that way we will know that, okay, this is the middle point. Very simple code. So how we represent this node in Java? So this is a example here. So this is our list node, which contains value and next. So next is basically address to the next element. So this is not just a value, this is a node. So it has like value and then address, data type, and then some functions, constructors. Okay, I'm not going to deep into that. So just I'll start with this. Will give me idea like what data type I will be using for the pointers. So for the first point, let's say I will make this name as 2 steps because I will moving this pointer 2 steps at a time. I'll be starting with head. Other pointer I will be naming as 1 step because this I will be moving 1 step at a time. So I'll name this also head, and I'll be running a loop obviously. So my terminating conditions will be it should not be null, and since I'm moving 2 steps, so I have to take care like next should not also be undefined, otherwise I will run into exception because I will show in the body what I'm doing. It will be more clear. Okay, it should not also be null. Why? Because 2 steps we are moving 2 steps dot next. See, so this cannot be null. That's why we have to also check this here. Otherwise, if this is null and whatever we are referencing, null dot something will give you exception, null pointer exception. So I hope you understand this concept. 1 step dot next. Okay, so while the 2 steps pointer is moving 2 steps at a time, 1 step will only move 1 step at a time. So while this pointer will reach till the end of the linked list, 1 step will reach to the middle of the linked list. So we can just simply return 1 step. This is very simple logic. I hope you understand this logic, and let's run this solution. It's accepted, submitting it. Okay, great. So this is the main, the basic concept of solving any problem in linked list. We have to know this thing, the representation, how it is represented and how it is stored in the memory. We can only navigate to one element from the start. That is the basic concept. So we will be doing more problems in linked lists so that we are like more comfortable here. So but now I'll say bye.